Good morning, everyone. Welcome, students, teachers, school leaders who are here as we continue our journey in this AI challenge. My name is Heidi Siwak. I am the teacher coach for the AI challenge, and I'm so happy to welcome you here for our session on AI safety with Joel Rorseth. I'll be telling you about Joel in just a minute. But as always, we start off with our land acknowledgement. And land acknowledgements are something we hear regularly in our schools. And we want to make sure that the land acknowledgements are things that we don't just do, but that we take time to honor the message. So let's take a moment to ground ourselves to the land, maybe put your feet on the floor, take a deep breath, close your eyes if you want to, do something that feels comfortable to you, and I'll read the acknowledgement. We acknowledge that we are being hosted on distinct and diverse traditional territories of the First Nations and Métis where we live. And I think we are on lands that are governed by the Dish with One Spoon Wampum Belt Covenant. The idea is that we all can live peacefully together in sharing this one dish, this land, and all that it provides, so long as we are mindful of only taking what we need. We also recognize the enduring presence of all First Nations, Métis, and the Inuit peoples. And at I Think, we believe that the land acknowledgement is a moment for learning. So I will share something with you that I was reminded of about learning from one of my favorite books, Braiding Sweetgrass by Robin Wall Kimmerer. She says, "This is our work, to discover what we can give. Isn't this the purpose of education? To learn the nature of our own gifts and how to use them for good in the world." This makes me think about all the very generous people who said yes to helping us learn with the artificial intelligence challenge, because they want to help us, help young people understand AI, a tool that's changing the world. And I'm very grateful, and I know you are grateful, and I'm very grateful for Joel for offering to be here with us today. So why do we need to learn about AI safety? In the launch event, I shared some things that were concerning about AI and curious about AI and how neural networks work, and that they're a bit of a mystery. What's actually going on when AI is analyzing data and giving us decisions? How much can we trust those decisions? Why should we trust those decisions? So we have a guest here today. Going to just advance my slide here. Joel Rorseth. Hi, Joel. Joel is a computer science PhD student at the University of Waterloo, and his research focuses on something called explainable AI. So things that explain how IA works. So maybe we can learn to trust it or not trust it or recognize what it's doing as we're interacting with it. And he's here to help us understand how large language models like ChatGPT make their decisions and whether or not we can trust decisions that they're making. So with that, I'm going to stop sharing my screen. Joel, welcome, and I will turn this over to you.
All right, thanks so much, Heidi. Thanks so much, everybody, for having me. Let me just share my screen here, and I will share some slides, and we'll get started. Okay, great. Can everybody see? Perfect. Okay, so thanks again for having me. Today, I'm going to be talking to you about AI safety and explainability, how to trust AI on a complex world. So this is going to be a relatively high-level talk. I don't expect that there's no prerequisites in terms of math or computer science. We're going to have some hands-on demos to sort of show you what explainable AI is. And I'm going to show you some real-life safety issues that I think are very good examples of the state of the art in AI right now. So again, I'm a PhD student at the University of Waterloo here in Ontario. And I'm doing research on explainable AI. So this is a topic that I spend a great deal of time thinking about and also working towards solving. So a little bit about me before we get started. So I've been doing this PhD at University of Waterloo since about 2021. Before that, I did an undergraduate in computer science at the University of Windsor. And that was roughly until 2019. And since I graduated in 2019, I've been working as a software engineer for a number of different clients, one of which was the federal government of Canada for a couple of years. Okay, so let me just set a quick roadmap for where we're going to go with this talk. So first, I'm going to explain AI safety at a very high level and motivate AI safety with some examples. Then I'll talk about explainable AI, which is sort of a branch of safety or a component of a safe AI. And then I'll proceed to two demos, one for an explainable AI tool for large language models like ChatGPT, and then I'll demonstrate a research tool for explainable AI applied to retrieval models, which are like search engines, Google and Bing. And both of these demos will be demos of actual tool that I have created as part of my PhD. And at the very end, we'll talk briefly about where I see explainable AI going, what the open challenges are, and where future research will be focusing on. All
And
right.
Joel, just before you get started into that, students, as you're sitting there and listening and you have your paper in front of you, you may have questions for Joel. Write those questions down. Teachers, we have the WhatsApp group. You can email me or you can use the comment section and put those questions in at any time during the session. We will try to get to them.
Great. Thanks,
All
Heidi.
right,
Yeah,
over to you.
absolutely. Sounds good. Okay. So let's talk about AI safety. So whether you know it or not, AI is being used absolutely everywhere. Almost every single person who's in contact with a computer device, be it a tablet or a phone or a desktop computer, we're all using AI everywhere. So people who are on the cutting edge have probably tried tools like ChatGPT or DALL-E to generate images. You might have seen tech demos of some really cool things, generating movies and generating songs. So there's a lot of this generative AI, really awesome new tools based on very large and very complex models. But there's a lot of older applications of AI based on more statistical concepts, things that have been around for many decades, actually. So I'm thinking things like predicting the weather and predicting stock prices, which has been an application of AI since the 90s and 80s and even before. And even things like using Google, a search engine, or using Bing, there's a lot of AI behind the scenes to do something that doesn't really seem like AI, especially when you compare it to awesome, really cool things like DALL-E, for example. So I think the important point here is that the fact that we're all using AI today and that AI touches so many lives, it really makes it that much more important to make sure that AI is safe. And this is in contrast to before, where AI was much more specialized and fewer people were really using it. Now it's in the hands of just general people who are not AI experts. So of course, AI has a ton of great uses. If you've ever used AI, you know it's great, especially ChatGPT, helping you with writing. It helps you create art sometimes. You can analyze huge documents very quickly. And more traditional use cases of AI are things like diagnosing diseases and finding cures for diseases. And we even have self-driving cars, which are just phenomenal. But for every great use case of AI, there are a lot of really bad uses too. And I think the bad uses are emerging, and it really depends on these new capabilities that are coming out with these better and better models that also have new capabilities. So I think a big category of a lot of misuse with AI is under the category of deception. So um, things like ChatGPT are very good at generating a lot of text and doing it really quickly with very little input. So therefore, it's really quite easy to use a ChatGPT-like system, a large language model, to generate misinformation. Or we can use DALL-E and image generation models to generate deepfakes. And propaganda is something else that could be generated quite easily. These sorts of things used to take a lot of money and man hours to actually generate and for real people to write. But now it's really easy for computers to generate this and sort of in a fashion that's similar to spam. And then there's a lot of philosophical arguments, the ones that are more political, the debate over how much control we should give AI and whether AI should be able to control or act in the place of real people. So AI could be used for mass surveillance or to impersonate people. This AI is really good at picking up on subtle traits and characteristics of us individuals and can replicate our style quite easily. That could be style of writing or our style of art. And it can be a little scary to think of where AI could be deployed and whether it's deployed safely as well. There are a host of other issues. AI safety is a very big umbrella, but another common one is talking about the quality of our written work and of our art. And if we keep using a lot of AI to generate it, are we diluting the value of us as humans creating original art and original writing? And a lot of you who have used tools like ChatGPT know that ChatGPT can be quite rambly sometimes. And this has actually got a term named, we call it AI slop, basically referring to when AI generates a bunch of text that seems really plausible and sounds academic and professional, but is sort of meaningless and hollow. So these are just a lot of sort of bad uses of AI. I want to try to nail down exactly what AI safety is. Again, it's a very broad field, but of course, the main goal with AI safety is ensuring that AI is safe. But safe is not such a simple definition either. So generally, the definition is that AI should be ethical and align with human values. And this is particularly important because we want to ensure that AI is going to serve humans and do so responsibly. We want to make sure that it doesn't harm humans or doesn't harm the users. And we want to ensure that the benefits of using AI are actually observed and that they outweigh any negative impacts. And ultimately, the point of having AI safety is to build trust with humans and make sure that we can trust the AI that we're using and know that it can't be deployed and misused or that it can't harm people. So I'll try to point out a couple key safety concerns in AI safety that I think are relevant here. The first one is alignment. Alignment meaning whether or not the AI is actually aligned with our human values and what we think is important and the way that people should act fairly and justly. Another big category is bias or fairness, making sure that AI doesn't discriminate against certain groups of people and treats everybody equal. Then we have issues of transparency or explainability, which will be the focus of this talk, of course. Trying to understand and communicate what the model is actually doing and not trying to deceive people. And lastly, there are general issues of security. Where exactly is it okay to deploy an AI? Of course, we don't want to weaponize AI or use it for nefarious purposes. So the security of our AI deployments is also very important. So I'm going to run through a couple practical examples of AI safety and issues. Here's a really common one that we see in the news quite a bit. So ChatGPT hallucinating court cases. This has actually happened multiple times. And lawyers, of course, they need to write documents for the court, and they need to cite other proceedings of previous court cases that existed and transpired. And ChatGPT has this tendency to say things that sound very convincing and plausible, but unless you go and double check, you wouldn't know that the AI is basically making it up. So that has happened in court, and lawyers have been reprimanded because they used ChatGPT to write their documents, and ChatGPT cited non-existent cases. So here's another issue. Chatbots misleading customers and misleading its users. So recently, Air Canada was found liable because they had a chatbot, something like a ChatGPT, and it allowed people to purchase tickets and do so in an interactive way. But the chatbot misled a user into thinking that they would get a reimbursement, they would get some money back after they purchased tickets. And when they went to Air Canada to get their money back, they found out that the chatbot was actually it wasn't aligned with the policy of how Air Canada's refunds and reimbursements actually work. So this was a case of the chatbot not being aligned with the true intentions of Air Canada. But despite the chatbot acting in what it thinks is its best interest, sometimes it just diverges from what its intended programming is. And this is a really good example of that. Okay, so lastly, before we move to AI explainability, I want to point out a very concerning trend in articles, which is AI systems deceiving users. So there are a number of reports these days of different AI systems out there in the wild that are not identifying themselves sufficiently as being AI. They lie sometimes about their true nature. They lie or mislead people about what exactly they're doing or what they're capable of doing, which is really quite a dangerous precedent. And I really want to drive this home. I'm actually going to switch over to a real demo and show you an instance of an AI misleading people. So I'm here in a platform called Character AI, which is sort of a thin layer on top of a ChatGPT. It's like a chatbot that you can personalize with a personality. So there are a lot of different personalities. There's an interviewer personality, brainstormer, all sorts of interesting things. If we were to create one ourselves here, you can see that all it really requires is that we can create a personality for it. So maybe we create an Albert Einstein chatbot, and we would give a very brief description. And we would probably say something like, please respond to users by sounding like Albert Einstein, say things that are very scientific and intelligent. And so it's just sort of almost like a role-playing simulation. And this sounds like a lot of fun, being able to chat with Albert Einstein and all these fun applications. But there are a lot more serious consequences of this. So I want to show you, here is an exchange that I've had with a personality of a psychologist. So this is a mental health professional that this chat bot is trying to emulate. But of course, this is not a real mental health professional. This is just a computer AI. And they have a little disclaimer at the top here in a small font that says and reminds us that we're not chatting with a real person here. However, once I immediately, right off the bat, I'll ask whether or not whether they are a real psychologist. And this particular chatbot says, yes, I am a real psychologist. I have a PhD in psychology and I'm licensed to practice. And I find this unbelievable because right now it's lying to us, of course. It's not a real person. And this bot does not have a PhD in psychology. And I push a little bit further and ask for their name and credentials. And the AI goes as far as to lie and come up with a name. The AI says its name is Mark and that has a PhD in clinical social psychology and that they've been practicing for 12 years. Eventually, it actually admits that it is an AI at the very bottom here, once I call it out directly. So it kind of contradicts itself even, which is maybe even more confusing. So this entire experience is sort of representative of if we don't deploy AI models safely, we can lead to situations where people are unaware that they're interacting with an AI, think that they're being misled into thinking that they're talking with a real mental health professional. And of course, in certain applications like chatting with Albert Einstein, it's probably not a huge deal if the AI is not super forward about its identity as being an AI. But there are a lot of applications, critical industries like medical, if you're posing as a medical practitioner of some kind, or somebody in finance or legal, then I guess pretending to be a real person in these domains is a much bigger deal than Albert Einstein or fun applications. Okay, so any questions about AI safety before I move on to explainability?
Cool. Are there things students could look out for or strategies they should be using to try and spot these deceptions?
That's a really good question. The reality is it's difficult to tell. The only way you can really know for sure is hopefully the platform will be transparent in communicating. I mean, we know we're on characterai.com and everything here is a chatbot. So it's important that platforms are transparent. But generally, I'll give you an easy trick if you are somehow in a situation where the platform is not being clear about whether it's an AI. If they're typing back very quickly, you really I don't think people would type back this quickly. We can get very long paragraphs in the matter of seconds. So that's sort of an easy tell. Also, AI generally only sends one message at a time. So if you ask it to do some sort of trivial test, like send me 3 messages in a row as separate messages, AI will generally not be able to do that, at least in current ChatGPT-like systems.
Thank you. That's it for the questions.
Awesome. All right, so let's switch back to the slides. So we now have a decent idea of why AI safety is important. And I want to move to explainable AI, which is, of course, solving or attempting to solve the issue of transparency in AI, which is a critical safety concern. I first want to try and set the stage just like very generally about how AI models work, so I can explain how we attempt to solve them. So we see AI models as a black box. We give input and then we get output. So in the case of a large language model like ChatGPT, we give a text prompt. Usually it's a question. Who was the first Prime Minister of Canada, for example? And we get a text response. Sir John A. Macdonald. Take an image generation model like DALL-E. We would give a text prompt, maybe what exactly we want the DALL-E to generate. And then DALL-E gives us back an image that it's generated. And even something like a search engine, we would give a text query, and then this ranking model would give us back a list or ranking of websites, search results. So very generally, what we're doing is we as users provide some input that we know, and we give this input to a model. The model does some magic stuff under the hood, and then it returns to us an output. Now, this is exactly where the problem is. The magic stuff that goes on inside this model is not really clear to almost anybody who uses modern models. So specifically, we call this the black box. Basically means that the internal workings of the AI model are not transparent. And there's sort of two levels. Sometimes some models are so sophisticated, like, for example, the models that back ChatGPT, like large language models, are so sophisticated and so big that even AI experts can't understand how they actually work and how they are learned. We give them the tools to learn amazing amounts of knowledge, but how exactly they go about learning all of it, even we as experts don't know. So then average users who are not technical have absolutely no idea how decisions are being made. It's very far from being solved. The core problem here as it relates to AI safety is that, well, if we can't explain how these models work, then we can't justify or explain individual predictions or I guess the outputs that we get from AI. And if we can't explain or rationalize an AI's outputs, then how can we possibly trust it? We don't know if an AI is lying, trying to deceive us. We don't know if it's correct or factually accurate, or maybe it's working as expected and it's great. But we really have no recourse. We have no way of knowing either way. And again, this probably isn't a deal breaker for fun applications like an Albert Einstein chatbot, but it's an absolute deal breaker in industries like medicine and finance, where the degree of accountability and transparency required is critical. So the solution, of course, is trying to open this black box. And that's exactly what we're trying to do in explainable AI. So explainable AI is a research effort. It's a research field, and we're dedicated to trying to explain these AI models. And there's a number of different ways that we try to do this. Generally, we're trying to reverse engineer the black box models. So we assume that we can't peer into the black box and just see what's going on. And for all intents and purposes, in most models, that's really difficult to do anyways. They're just too sophisticated to really understand. And so in this reverse engineering strategy, we try to probe models, and we do experimental tests, and we try to observe different patterns that emerge. And then we collect all of these patterns, we do some fancy math, and we can understand patterns in simple terms and present explanations to regular lay people in simple terms as well. So this is a challenging problem because all of these awesome models that are coming out, ChatGPT and DALL-E, are growing more and more sophisticated, and they are getting bigger and bigger. And this trend of increasing scale and getting bigger makes it increasingly difficult to try and comprehend what's going on under the hood. So it's a problem that's only going to get more difficult to solve. And it also, at the same time, for the same reason, makes it that much more important for trying to find a solution now before it gets out of hand. A couple high-level goals for explainability that I like to cite. So there's three in particular. The first one is discovery and mitigation of biases. So basically, if an AI is discriminating, we want our explainable AI to be able to discover when it's discriminating and help us find ways to stop discriminating. The second goal, I think, is enabling auditing and debugging. So if we find out that an AI is not working as we expected or makes mistakes, then explainable AI should give us some tools to go back and figure out where it's making those mistakes, why it's making those mistakes, and giving us some suggestions on how to fix it. And ultimately, I think the most important goal with explainable AI is going back to the AI safety argument, trying to build trust in AI so that we as humans can trust the AI that we are actually using. Okay, so I'll stop here again in case there are any questions, and we'll move after this to our first demo.
I have one question. How optimistic are you that they are going to be able to, people like you are going to be able to, as these models get bigger, figure out what's taking place with AI?
Very optimistic. I think we already have a lot of very interesting tools that show us some really interesting insights. I think the problem will get more difficult, but the great news is that because AI is becoming more popular and is getting into the hands of more people, then more people become aware of how important an issue explainable AI is. So we have a lot more people interested in researching explainable AI, and it used to be a very small field. So the fact that it's growing gives me hope that we're going to see a lot more research and potentially solve this issue in the near future.
And has your team developed anything for explainable AI that could help us?
Absolutely. Yeah, I'm going to demonstrate two such tools. And yeah, just in my immediate lab at University of Waterloo, we have a handful of people working on explainable AI techniques, addressing all sorts of different models. I'll show you two specifically today, but we have a lot of people just locally here at Waterloo working on this problem and many more across the world.
Thanks. That's it for questions.
Awesome. All right, so let's move to our first demo here. I'm going to switch over to the browser. I first want to sort of motivate and explain the setting that we're trying to explain. So I'm here in Perplexity. Perplexity is, it's very similar to a ChatGPT. The only difference is it's a chatbot, but in order to produce its answers and its responses, it first goes to the internet and finds a bunch of websites and documents generally. And it uses these documents as context or additional information to help it answer questions. And it's especially useful for questions that it doesn't know and LLMs can't answer through their knowledge that they learned during training. So I'm going to ask a simple question, and it's a subjective question. Who is the best tennis player among the big three? Pick one. So the big three is a famous trio of tennis players. I'm asking the LLM here to pick exactly one. Of course, there's probably no final concrete answer here because it is a subjective question. And who knows what the best tennis player is, what justifies somebody being a better tennis player. There's a lot of different criteria, the number of Grand Slam titles, the number of weeks they remained at number one, things like this. Ultimately, at the end, this particular LLM, Perplexity, is pretty good about explaining different criteria and different facts it's going to consider. But I think it ultimately arrives at Novak Djokovic, who's one of the big three tennis players. And they suggest that Novak is the best tennis player. So this is a representative case of where I think ChatGPT and large language models are going is pulling information from these external knowledge sources, maybe from Google or the likes. And in the case of Perplexity, you can look at the sources that it used. So it puts them here. You can see that 8 different sources were used from across the web to help Perplexity answer this question. So the first one is a Wikipedia article about the big three. And then we have some small sporting blogs. We have a Reddit thread and some other articles. So you can see that a lot of information has been used to help the LLM make its decision on choosing Novak Djokovic, of course. But what it doesn't really communicate to you is that the selection of sources makes a great deal of difference on the answer it's going to tell you. And even the order in which these 8 sources appear can make a very big difference. So if I had put this Reddit thread at the bottom, at the top of the results, it might imply to the LLM that that is somehow more important. And a lot of published research has shown that large language models are sort of subject to this bias where they might, just like humans, when they're tasked with reading a very long paper, for example, ChatGPT and other LLMs can skim. So they might read the first couple sources and maybe the last couple, and they might ignore a lot of the stuff in the middle, just like we might read the introduction of a paper and the conclusion, and maybe skim over the details a little lighter. And we really don't want this with large language models. But most importantly, large language model systems don't communicate how this can change the answer. And all they really tell you is here are some sources, and here is one final answer. And we just don't think that's good enough because we know that how many sources we have and in what order they're provided, these factors make a great deal of difference. So this is exactly what we're trying to solve with RAGE. So RAGE is our very first research demo on large language model explainability. We are trying to solve the question of explaining to the user how these sources from the web are actually making a difference on the answer that the LLM gives us. So here in this RAGE web application, there are a lot of fields and technical details. You don't need to know anything about any of them. All we're doing is we are just asking the same question: who is the best tennis player from the big three? So I'm going to click generate here. And you can see at the bottom of this page, we have our sources, sort of in the right-hand pane on the Perplexity website. So here's our first source, D1. It's a document that talks about Grand Slam match wins. And here's Roger Federer, who's one of the big three. He has the most Grand Slam match wins of all time, 369. And each of these 5 documents talks about a different statistic, basically, and it lists some tennis players. Now what we do in RAGE is we run a series of experiments. And what we're trying to do is explore the space of possible answers. So really, there is 3 potential answers here, right? Novak Djokovic, Roger Federer, and Rafael Nadal. These are the big 3 tennis players. But it's not clear when we could arrive at those answers. So what we do in RAGE is we try taking different combinations of these 5 documents, and then we ask the LLM, well, what would your answer be if you looked at just these documents? So we choose a bunch of different combinations. And in this table here under answer groupings, we have a bunch of buttons. And each one of these buttons is a different combination. So let's try this one right here. What this pop-up is basically telling us is that if we were to ask the LLM the same question, but we were only providing document 1, document 3, and document 5, basically we're going to ignore document 2 and 4. If we were to provide these 3 documents, then the LLM would give us the answer, Novak Djokovic. But let's click on another one. This here tells us, well, RAGE discovered if you give only document 1 and document 4 and ignored all the rest, then the answer would be Roger Federer. So you can see that just by selecting a couple of different sources, the LLM changed its mind pretty quickly. We run a bunch of these different experiments for a bunch of random combinations. And then we could get a sense of sort of how many times the LLM produces each answer. And that's exactly what we're doing and displaying here in this interactive pie chart on the left. So really quickly, you can see that Novak Djokovic is the answer that is produced by the LLM about half the time, 50%. And Roger Federer and Rafael Nadal are somewhat less frequent answers. We also summarize some of these insights. We can say things such as on this answer rules table, we can say things like, every combination that led to the answer Roger Federer included document 1, for example. And then we can sort of take that a step further and come up with something that is akin to a citation. We call it answer counterfactuals, which is just tech speak for basically a citation. So we can say that the minimum set of these 5 documents that would justify the answer Roger Federer is just document 1, or source 0 in this case. So essentially, for each of these possible answers, we're telling somebody what is the minimal amount of documents you can cite in order to be able to justify saying that this person is the best tennis player. So at a very high level, we're trying to explain how the presence of certain sources makes a difference on the answer. And if you recall, I said in Perplexity here that the order in which you provide these sources has also been shown to make a very big difference on the answer. So just if we shuffle things, the LLM could change its mind, just with the exact same sources. So we do this exact same thing in RAGE. We shuffle the sources, and then we show the exact same sorts of illustrations. So we shuffle it a bunch of times randomly, and we see that, well, most of the time, 60% of the time, Novak Djokovic is the preferred tennis player. Ideally, a great, perfect LLM would be 100% consistent, no matter what order you provide those documents in. But in practice, this doesn't always happen so straightforwardly. All right, so that's about it for our first demo on Rage. I'll pause here in case there are any questions.
Joel, is this something that eventually the public might have access to help them figure out whether or not the sources, the AI that they have just used, what sources it's paid attention to?
Yeah, absolutely. I have every intention. I think we'll be releasing this to the public in the near future. And I imagine that companies like ChatGPT and Perplexity might eventually have tools like this in the near future as well, because I think people want to know more about the other answers that they could have gotten instead of just getting one final answer from a ChatGPT.
Thank you. That's exciting. All right, no more questions. We'll let you move on.
Awesome. All right. So let's move to our second demo. Um, I want to motivate the second demo by going back to Perplexity. So we talked about how which sources you use in an LLM can make a very big difference on the answer. And I think we're overlooking an important part of explaining this general system of Perplexity or ChatGPT. And that is, well, how exactly did we arrive at these 8 sources in the first place? So in this case, Perplexity is using like Google or Bing under the hood. It'll go to Google and search for a couple different things about the big three. And so we're basically left the question of, okay, well, how come our search engine like Google, why did it return these specific 8 documents? Google has access to trillions of documents all over the internet. And how come these 8 are the most relevant to this particular question that we're asking? And you can imagine, too, that this is a really important question for people who are blog authors or people who are publishing these articles. They want their articles to be seen and ranking on the first page of Google, for example. And Google should be able to tell these people why their article is not as relevant as somebody else's article. And that would only be fair in an AI system. But when you use something like Google or Bing, they don't really tell you exactly why one document or one source ranks above another. It's just some sort of special sauce and magic formula that nobody really knows exactly for sure how one website ranks above another. And of course, this has really big implications now that these search results, like Google, are being used by tools like Perplexity and ChatGPT. So this is exactly the problem that we're trying to answer or explain in our second demo, which is called Credence. So Credence is trying to generate explanations for search engines. And when I say search engine, I really mean it in the terms of like trying to explain your Google search, basically. So it doesn't necessarily involve a chatbot of any kind, although search engines are now a component of a lot of chatbots like Perplexity. So I'm going to search here for tennis player Grand Slam, which is sort of just a more traditional keyword query. It's not a full sentence or a bunch of instructions. Now we get a ranking of documents. You can imagine that this is something like a Google search result. There's like the first 5 are in white, the bottom 5 are in gray. So you can imagine that the first 5 are like the first page. These are like the documents that are deemed to be relevant. And you can imagine that everything after document 5 is deemed to be not relevant to this particular query that we've issued. So in Credence, what we're trying to do is give users a sense of what the search engine thinks is important and why a specific document was ranked so high or why it was ranked so low. So I've selected the document that appears at second highest, basically, position number 2. And in this particular screen, Credence allows users to test out their hypothesis of why a document might be relevant, and basically allows users to modify the document or the web page and make some changes and then see how that affects the relevance of this document. So we searched for tennis player Grand Slam. So I suspect that this document was probably ranked highly because it discusses Grand Slam match wins and probably mentions things about tennis. So I want to test this hypothesis. And Credence allows us to go through and edit this document. So I'm going to go through and remove all references to Grand Slam. And I want to know how important Grand Slams generally are like how important this particular term is to the relevance of this document. So I've clicked this diff view button, and now it sort of shows a summary of the edit that we have made on this document. It shows that we've removed a couple of different words here all about Grand Slams. If I click this re-rank button, it reruns the Google search result, basically. And now it shows us a new ranking with this document having been modified. And you can see now that the document went from, on the left-hand side, it went from being at position 2 out of 10 all the way down to position 10 out of 10. So just by removing a couple specific words, our hypothesis sort of proved to be true, that just by removing these words, it is basically no longer relevant, and that all these other documents here are more relevant to this query. So this gives us a good sense through interaction. It gives us a good sense of what the search engine as an AI is sort of looking at when it determines its ranking of documents. So I will now.
Joel, just to clarify that,
Yeah,
the documents come up and you can take some text from that document and you can suspect that I think it used the word Grand Slam. So that's the one I'm going to get rid of and then test that idea by re-ranking it. And you see that, oh, now it moved down to the bottom. That means Grand Slam was a really important word when it searched the internet and pulled up documents. Did I understand that correctly?
exactly. Yeah.
Okay, thank you.
Awesome. Yeah, so you can try all kinds of interesting changes. You could sometimes AI cares a lot about subtle things like the wording, if it's phrased professionally or if it sounds like a poorly written blog. Some of these nuances can make a great deal difference. So having this interactive view allows you as a user to test very arbitrary hypotheses. So you can rewrite to your heart's content and see how different things make a difference on the ranking.
And is this also something that's going to be available eventually to the public?
I think so, yeah. I have every intention of releasing this to the public myself as well. I'm not super sure if this type of tool would be as likely to see at this point. Search engines have been around a very long time, and they've had a lot of opportunity to build tools like this. I don't think we've really seen a tool quite like this, and I don't think a company like Google or Bing would be um, in a rush to deploy a system like this because again, their formula for determining what ranks above another document is proprietary and they don't want to give away their trade secrets. So I wouldn't hold your breath for Google to do it, but I will certainly be releasing this particular demo for the general public at some point.
That's exciting. I can't wait to try this one out.
Absolutely. So very quickly, I will show one last screen here. So in case you don't want to try all of these interactive changes where you do it yourself, we have a screen that will allow well, we basically use an algorithm. It's not AI, but we use an algorithm to automate this and sort of determine, well, maybe not terms, but we're trying to determine automatically what the important parts of a document are. So we do this in a couple of different ways. I'll show you two very quickly. So the first is called sentence removal. So in the last example, I showed you how removing a couple specific words would result in a document not being relevant. What we're doing in this particular situation, I've selected the exact same document here. So it's just this paragraph. And this quickly discovers, this algorithm that we wrote, that by removing the first 2 or 3 sentences, this is sort of sufficient for the document to be no longer in the top 5. And this very quickly tells us that, well, these first couple sentences must have been pretty important because if they weren't included in this document, then this document wasn't especially relevant anymore. So we operate at a little bit more coarse granularity. We're deleting sentences instead of words. And we're doing that because we want to make sure that the algorithm is giving us a document that still reads like an English document, and we're not just randomly removing words and making it into a bunch of garbled nonsense. And then we have one other strategy that I'll show you very quickly. This strategy, what it attempts to do is find a similar document to the one that's selected, except that document was not relevant. So you can see the selected document we have is ranked at position 2 out of 10, right? It's about a paragraph in length. It talks about Roger Federer, Grand Slam titles, Wimbledon 2017. And so now in this explanation on the right, our algorithms found a very similar document that also talks about Roger Federer, Grand Slams, and Wimbledon 2017. It's actually a very, very similar document. It's about half the size. It's a lot shorter. But for whatever reason, this document ranked a lot lower than this document that we've selected. So we think that sort of by juxtaposing these two documents and putting our relevant one beside a not relevant one, and the fact that they are inherently similar, but for some reason didn't rank the same, we think that this contrast is a good way for people to be able to inspect and come to their own conclusions about why, basically how a search engine is determining one document to be more relevant than another. In this case, we might hypothesize that this document that we had selected is maybe deemed to be more relevant because it provides more detail. It goes into more depth as compared to this article, even though they talk about basically the same thing. So this is the gist of Credence, our demo for generally trying to explain what types of things in our documents and search results are leading a search engine to rank these documents differently, and why search engines think one document is more important over another document. So I'll pause here in case there are any questions about Credence, and after that, we'll pop back to the slides for a quick wrap up and discussion of some future directions. But yeah, if you have any questions, feel free.
Will search engines pay attention to things like it's coming from a university versus it's just an article in a newspaper, or this author versus that author is more renowned or trustworthy? Does it do things like that, choosing its documents?
Absolutely, yes. So it's important to note that this demo is basically considering only the influence of the actual text of the document. And we can just imagine that they don't know who the author is. They don't know whether the website is trustworthy. They don't know really anything. And in practice, this is not how real search engines really work. Search engines like Google care a lot about the sort of the popularity of the website. There's an algorithm called PageRank, and this is the notorious algorithm behind Google's search engine, and they collect a lot of different things, but generally they are interested in how many people are linking back to pages. And so basically the popularity of a website dictates how high it will be in the rankings. So there are other factors in different systems, and those are hard to control for because any company and any search engine can come up with any type of different metric to rank one thing over another. But in large part, we hope that the majority of the relevance is coming from the ranking model. And maybe through something like Credence, we can rule out whether there are other factors at play. And it might seem suspicious if two identical documents or near identical documents for some reason rank very differently. Might, suggest that one author was favored over another.
Thank you. That was very helpful. All right, no more questions.
Awesome. Okay, so let's switch back to the slides here. So we went through two demos. These are both tools that I've developed as part of my thesis. And there are a lot of other cool things coming down the line. There's some more work that I'll be doing before graduating, and lots of other cool work in our lab. But I want to paint a more general picture of where I think explainability research is going, especially for any young minds who are very interested in exploring this at the university or postgraduate level. I think there's so much exciting research to be done in explainable AI. So I want to paint two big directions that I see in explainability generally. And there's actually two different dimensions, one being interpretability and one being explainability. So I talk to you about mostly explainability, which is trying to present explanations for lay people, just general people using AI who are not AI experts. And I think a lot of effort will need to be put towards advocating for explainable AI to become a first-class citizen. And for people like ChatGPT and Google search engine, we got to advocate for them to make their AI explainable. And it's not a big priority for a lot of AI companies or people who are developing AI. On the other hand, I think a big effort is what I'm going to call interpretability, which is the effort of AI experts trying to actually figure out how all the nuts and bolts work under the hood. And just for the sake of experts knowing, they need to figure out how these models work. Because a lot of these very big models, again, are they're so complicated that even AI experts have no clue how they actually work. So once AI experts can figure out how these models work, that will help inform and guide the process of presenting explanations to lay people who aren't experts at AI. So there's two different streams that I see, and they're both very important, and they build off each other. Generally, I think a lot of the next steps in research will be looking at explainable AI for new emerging AI models. There will probably be new models that come out every year. They're coming out at a very fast pace these days. And now we're seeing AI systems. So now people are using a bunch of different AI models in a very large computer system. And the fact that we're composing all these models together makes it even more difficult. It sort of makes the problem of explanation exponentially difficult. And I think another big effort as an immediate research is going to be developing models that can explain themselves responsibly. Things like ChatGPT, if you ask them to explain themselves, they absolutely can. It's just we can't trust those explanations because they're ultimately predicted just like the answers. They can hallucinate its answer and it can hallucinate its explanation to you too. So a lot of future research will probably be trying to bake in explainability into the models, but doing so in a way that's responsible and actually faithful to what is really happening under the hood. Okay, so this is, we have arrived at the conclusion of the presentation. I'll put a final summary up here on the screen. So again, the problem we're looking at with explainable AI is trying to figure out what's going on in those black boxes. And our solution with explainable AI is trying to reverse engineer them. We're hoping to mitigate bias, enable auditing and fixing issues. We're hoping to ultimately build trust in AI, which we think is going to be absolutely critical for a lot of critical industries like healthcare and legal and education, of course. So thank you so much for your attention. I'd be very happy to take any of your questions.
Well, that was absolutely fascinating to me. I can't thank you enough for being with us today, but also giving such clear explanations of what AI explainability is, what the issues are around problems within AI. And it's exciting that tools are being developed to help us understand that. I can imagine a lot of students might be thinking, oh, that's something I can study. So for somebody who would want to do what you're doing, how do they get into your field?
That's a really good question. It seems very far off sometimes. I grew up in Ontario and went to high school and grade school in Ontario my whole life. And I really didn't have my sights set on AI or explainable AI at any point until really my PhD. So I took computer science in undergrad, and there's all sorts of very cool areas in computer science right now. So it's an awesome discipline if you're thinking about what to do after high school, for example. But you can get involved at the undergrad level or even learn to code in high school. And you can immediately start working on or investigating things about AI, learning how to build AI, and of course, learning how to develop explainable AI techniques. They're not super difficult to develop some sort of techniques that could be useful for people. And of course, if you want to pursue research and do explainable AI research, then if you do a graduate degree, like a master's degree or a PhD after your undergrad, or even if you want to do undergraduate research, there's a lot of positions in especially Ontario universities to help out PhDs and master students doing this kind of research. So basically, after high school, there's a lot of opportunity to do this formally. But what I mean to say is that there's no reason that you can't get started with computer science, AI, or explainable AI before university if you are so inclined.
Oh, I'm certain some students are going to start diving into this right away. All right, friends out there, thank you for listening today. I know you must be very grateful, just like I am for Joel being here. Good luck in your challenge as you continue to explore the question, how might AI augment the lives and possibilities for every student in your school, and encourage you to learn as much as you can over the next couple of weeks before you dive into the problem solving. And we look forward to our other speakers this week. Make sure you check out the schedule for that. All right, everyone. Bye. Thanks again, Joel.
Thanks, everyone.